In this video, we're going to look at manufacturing processes. In fact, we're going to look at loads of things. This is a fairly big topic, and here's a rundown of what to expect. First of all, we're going to look at production inside a factory, and then we'll take a look at how factories affect society around them. We'll then get stuck into the sort of processes that we find in factories, starting off with metal processes of sand casting and die casting, explaining how they work and what features arise in the products that they make. We'll take a look also at 3D printing and laser cutting. And finally, we'll look at plastic processes, specifically injection moulding, vacuum forming, and rotational moulding. But let's go back to the start of that list. Start off by looking inside the factory. There's two concepts of factory production that I want to introduce you to just now: one-off and mass production. One-off production is when a very small number of unique products are made, and these are usually made by highly skilled workers. The products tend to be exclusive, meaning that there's not many of them, and that they're expensive as well. Examples of one-off products may include things like engagement rings or wedding dresses, statues, and custom products such as some custom cars and things like that. At the other end of the spectrum then is mass production. Now this is when a huge number of identical products are made. There's lots of automation to be found in mass production lines, lots of machines, lots of robots, but hardly any people. And the workers that tend to be employed in mass production lines tend to be low skilled. These products also tend to be inexpensive and cheap. And they're things like common household goods, like plastic bottles and pencils and PlayStations and things like that. On screen here are some links to some pretty helpful YouTube videos which explain the difference between one-off and mass production. In those videos, we saw that mass production methods tend to rely on quite a lot of automation, quite a lot of machines, quite a lot of robots. This in its entirety is called computer-aided manufacture. And there are benefits and drawbacks of using CAM, as we sometimes call it, in factories. The benefits are, because you've got machines producing things all the time, you get very few defects, hardly anything goes wrong with the products themselves. The products, because they're coming out in their thousands and millions, become very low cost. And if you're a factory owner, one of the benefits is that it requires fewer workers than if you were doing something with a bit more skill involved. But there are drawbacks as well. You'll find that they're very expensive to set up. These are entire factory lines which need to be completely automated. So you need a lot of money to get one of these factories built and off the ground. The workers must be trained as well in computer-aided manufacture, specifically at the end where the programming happens and the 3D modelling and the data that gets created and sent to the machines. Those workers need to be trained. At the factory end of things, one of the drawbacks is that the number of skilled workers in the factory tends to diminish, and that has a wider impact on the society around the factory. So we'll skip over this slide. This is really about introducing that idea of mass production and society. You see, as soon as a factory pops up somewhere, it starts to employ people, and other people that had different jobs in different companies which the factory replace tend to lose their job, and basically society changes. The positives of having mass production in a society are that the products become cheaper and a lot easier to buy. We tend to end up with a larger range of products as well. Our shops become full of things that have been produced in factories. The products become higher quality. There are, as said in the previous slides, there's fewer defects going on. And there are some highly skilled jobs available, particularly in jobs that involve the design of the actual machines and the actual software and the programs that create mass production. So those jobs tend to be highly skilled. But the negatives are that low skilled workers can lose their jobs because there's just not as many of them required for a factory. As a consequence of that, unemployment can rise in the area. More people end up out of work. Those that remain in work become de-skilled. They become effectively like button pushers, operating machines rather than doing the thinking and the creation of things. And also mass production obviously creates quite a lot of pollution. It can create pollution, which can harm health, the health of people in the area, and therefore harm the wealth of people in an area too. Got some past paper questions here, which you can pause the video and along with some model answers about how you answer these sorts of questions. And we'll just skip past these and move on to take a look at metal processes. So we're going to look at a couple of metal processes that are used in factories. The first one's sand casting. And sand casting is when you create a mould out of sand, a special type of sand which has been soaked in oil, so it becomes really easy to shape and it holds its shape really well. You then pour hot metal into the cavity made in the sand, and it cools and it takes on the shape of the cavity. This is sand casting. It's really versatile. It's used all over the world, but it is very labour intensive. That means you need a lot of people in the sand casting production line in order to make it work. You can sand cast large parts and small parts at the same time, and it's fairly accurate. It's not super accurate, but it's fairly accurate. You could tell something had been sand cast because the surface of it takes on the texture of the sand. It has a kind of orange peel-like quality to it. Items that have been sand cast also have, if you look very closely at them, they have these things called draft angles, which means their sides are not exactly vertical. There's a very slight slope on them. And that's to ease the removal from the mould. Sand cast products also have quite a lot of rounded corners and rounded sort of internal corners, which we call fillets. And if you look very closely, there'll also be a tiny flaw running all the way around the part, which is the mould split line. That's an indication of where the two halves of the sand cast mould came together and a little bit of molten metal just seeped out. I've also got in this slide a couple of videos that we can watch about sand casting, so if you get a chance, you should definitely check those out. Die casting is an automated form of metal casting. It is very, very similar to plastic injection moulding, which we'll look at later. But die casting allows automated manufacture of complex, accurate metal parts. And when a part comes out of a die casting machine, it requires very little finishing, very little filing, sanding, or surface polishing, because it comes out with a really high surface quality. Now, if I handed you a piece of metal and asked if it had been die cast or not, you'd be able to tell if it was, because it would have this super shiny, super excellent surface finish to it. It would be incredibly accurate, and it would have complex shapes and complex forms, and by that I mean it would look as though it had been sculpted. Lots of curves, lots of roundness, rather than looking like it had been put together out of rectangles of metal. There are little flaws as well that you would spot in a die cast part. You'd spot the little indentations made by the ejector pins. They're in blue in my animation there, where the ejector pins pop the part out of the die and leave little circular defects on there. You would also spot a mould split line, just like in sand casting as well. And you may spot little dimples and little flaws where the gates and the runners, where the actual molten metal had arrived at the part and had since been cut off and removed. Little sprue and gate marks, as they're called. This was a classroom exercise where we're trying to figure out if something had been sand cast or die cast. Okay, and the first thing we'd look at here is a bracket. Okay, and asking, has it been sand cast or has it been die cast? What do you think? Well, it's been sand cast, and we can tell that because it has that rough surface, that kind of orange peel-like surface. You can notice also that it has rounded corners everywhere. There's hardly a sharp corner anywhere. The internal corners, the fillets, are quite generous as well. And around the base of it, you'll see the little flaw, the little mould split line as well. All these things indicate that it's been sand cast. What about this vise right here? Look closely at it. If you do, you'll notice that it too has been sand cast, because it has that rough orange peel-like surface. There's all those rounded corners, and there's the generous internal fillets as well. What about the metal part of a toy car? Sand cast or die cast? Well, I can tell from the photo that it's shiny, as a good surface quality. That's the first indication that it's been die cast. And it's also a detailed shape. It looks as though it's been sculpted. Tells us, both those things tell us that it's been die cast. And finally, this pump part right here has been sand cast or die cast. Well, it has also been die cast. We can tell that because it has an excellent surface finish. Compare it to the first bracket that we looked at. There's just not that dull orange peel-like quality to it. It's a complex shape. It looks as though it's accurate, and we know that it's not been sand cast. We know that it's been die cast because it has sharp, crisp corners on it as well. So what about 3D printing and laser cutting? Well, 3D printing is an additive process. Okay, and this you can make prototypes and models and engineering parts using 3D printing. You need to start off with a digital CAD model, a 3D CAD model in a computer. You then send that to a 3D printing machine. And the object is then built up layer by layer very slowly using hot plastic or resin or in fact concrete, which can be 3D printed as well. Very little waste with 3D printing. And you can tell that it's been 3D printed because if you look really closely at that green part on screen just now, you can see the layers that it's been made up of. It's got kind of very fine ridges across it. In modern 3D printing, those ridges are now almost invisible to the eye, but they're still there. The advantages of using 3D printing is that it's a really accurate process and it produces very little waste. It's also a super fast way to get prototypes, to be sitting in front of a 3D modelling program and ask yourself, I wonder what that part looks like in real life. You hit a button and the printer will give you the actual physical part in an hour or two. The disadvantages of 3D printing is that the machines can be expensive, particularly the modern super accurate ones. In order to do 3D printing, you need special software and you need to be trained, and they tend to only be able to print one material at a time, although some 3D printers can do multicoloured parts, not all of them can. Let's move on and take a look at laser cutting. Now this is a process that's used on thin sheets of material, wood, metal, plastic, something like that, where a laser literally cuts through the material. Again, the cutting path, a bit like 3D printing, this is all controlled by a computer, in this case working off of a 2D drawing rather than a 3D model. So it can produce incredibly accurate and very intricate shapes. You'd find laser cutting getting used to make anything that involves a sheet object. So chassis for the insides of computers and games consoles, toys, puzzles, decorations, things like that. The advantages and disadvantages of laser cutting. The advantages are that it is very, very accurate. Pretty much whatever you can draw on a computer, it can cut out of a thin sheet material. There's very little waste generated as well, because what you're able to do is if you've got lots of parts to cut out, you can arrange them all in the sheet so that there's hardly any gap between them. And once the laser's cutting away, particularly with plastic, is it leaves a really, really smooth and high quality edge, because the laser effectively melts the edge of the plastic and causes it to kind of become shiny. So you get a really high quality edge out of laser cutting. Disadvantages: machines are expensive. Again, just like 3D printing, you need special software and you need quite a lot of training to be able to do laser cutting. And it's only limited to thin sheets, so you can only really cut through, I don't know, maybe a few millimeters of material at a time. Let's look at plastic processes then. We've got 3 of these to cover: injection moulding, vacuum forming and rotational moulding. Let's start off by looking at injection moulding. This is almost identical to die casting. In die casting it's hot metal, and in injection moulding it's hot plastic that gets squeezed into the mould. Injection moulding is a highly accurate manufacturing process. It can create really complex looking parts, and they come out of the machine with a superb surface finish. It's very versatile as well. You can injection mold large things like entire chairs, or you can injection mold small things like Lego bricks. But it's only suitable for mass production. That's the thing about injection molding, is these machines are super expensive and they're huge as well, and they need to be connected up via pipes and all kinds of other parts of the factory. But it's an incredibly common method of manufacture. It's used to make toys, tubs, electrical products, things like that. Lego bricks as well, they're made from injection moulding. And right there on screen just now is a link to a YouTube video, which is definitely worth watching. Now, how can you tell that something's been injection moulded? There are several telltale signs. Just like die casting, there are little ejector pins that release the part from the mould, and they leave a little mark on the product as well. Also, like other forms of casting, we have draft angles, we have slightly sloping sides so that the parts are easy to remove from the mould. We can tell that this orange thing has also been injection moulded because it's got complexity to it. It looks sculpted. There are curves intersecting with other curves and walls and all kinds of things like that. That can't really be done by hand, that has to be done by an injection moulding machine. We're also looking for mould split lines, little flaws that indicate where the two halves of the mould came together. They're hard to see, and good designers will hide the mould split lines, but nevertheless they're there somewhere. And also what we notice about injection moulding is that the whole thing seems to be made out of the same thickness of plastic. The plastic doesn't really change in thickness, not by much anywhere, and that's for reasons of cooling and distortion on a plastic shape. But it means that you find these thin walls, and you find what we call little strengthening webs, little internal walls that are supposed to give rigidity to the part, and they're one of the signs of injection moulding as well. Let's move on and talk about vacuum forming. This is something that we do in school, something that you've possibly done in the workshop before, where you get a thin sheet of thermoplastic, you heat it up until it becomes soft, and then the plastic is placed on top of a mould called a pattern, and then somewhere else in the machine there's a vacuum pump and it sucks out all the air and it draws the plastic in tight to the pattern. The plastic then cools and it takes the shape of the pattern underneath it. And this is typically used to make quite a lot of packaging, some toys, trays, things like that. The little plastic tray that your fruit comes in is probably made from vacuum forming. Or the little flimsy plastic tray that holds assorted chocolates in a box is probably vacuum formed as well. How can we tell something's been vacuum formed? Here are the features on this red thing right here. So pretty much anything that's ever been vacuum formed is an open shape. It looks like a tray of some description. There are large rounded corners everywhere. You will hardly find a sharp corner on anything that's been vacuum formed because the sharp corners tend to tear the plastic. And there are sloping draft angles again. Vacuum forming, they can be quite generous, quite easy to spot, unlike in injection moulding where they're quite difficult to spot. But in vacuum forming, the slopes are obvious. And again, because it's a sheet material, we would expect vacuum formed objects to only be made of thin sheet materials and having thin walls. Now then, let's look at rotational moulding. Rotational moulding is an interesting one because you take some thermoplastic pellets and you put them into a large hollow mould, a bit like an Easter egg, let's say, but enormous. And you heat that up and you start to spin the mould, and the plastic becomes molten inside it and it starts to slosh around and it starts to coat the inside of the mould. And then you start to cool the plastic and the plastic hardens and basically it takes on the shape of the inside of the mould. And this sort of process is used to make large hollow objects, things like suitcases and bins and canoes and some toys as well. And there's a YouTube link there that you can follow to see rotational moulding happening in a factory. So how can we tell if something's been rotationally moulded like this kayak right here? Well, it's entirely hollow. That's a clue that it's been rotationally moulded. It's massive, which is also a clue. That there are no mould split lines anywhere to be found. There are none of the flaws of the other plastic processes. And if we look super closely, we'll discover that the product has a uniform wall thickness. That means that it's the same wall thickness all the way throughout. So that concludes the video lesson on manufacturing processes. We looked at production in a factory, we looked at how those factories affect society, and then we had a quick tour of some of the processes: sand casting, die casting, 3D printing, laser cutting, injection moulding, vacuum forming, and rotational moulding.